Good morning, everyone. The last time we met, we told you about what we are building as a company and the challenges we are facing. So I'm happy to say that we're back again, this time with more vision and more about the product. So we've built an application, dashboard called Energify, and the goal of Energify is to optimize energy efficiency for buildings. So what's the main motivation behind having such an application or a dashboard, and why are we building it for this region, living in north of Sweden? So we try to understand this by a simple use case. I want you to meet Greg. So Greg is a power engineer who has recently moved to Skellefteå, and now he's employed at a university, and his main responsibility is managing power for the entire university. And he's concerned with paying bills, optimizing resources, and taking care of basically budgeting for electricity costs. And he's equipped with 6 buildings in the university, and he has the task to talk to the company board which provides electricity in our city, and find what's the best for the university. So Greg sets up a meeting with the electricity board, and the electricity board says, "Hey Greg, you have 3 options to pick from. You have a fixed electricity price which you can pay, there is no variation, and it's going to be like the safest option for you. Variable electricity price, if you plan to use less electricity, you can go with a variable electricity price. And then if you are really good with optimizing your resources, we have a hardly electricity price. So you pay like the least amount for certain hours of the day, but you pay like really more when you use it in peak hours." So now Greg remains confused. What am I going to do? Because I have 3 options. Just like most people, he would go for the recommended option, which is the fixed plan, safest option, with the company electricity board. And then he discovers he's ending up paying a lot more than usual. And Greg is really concerned. Why is this happening? And then he thinks, okay, maybe I should try to switch to a different plan. And next day, Greg talks to the company board, and he comes to know that they have the hourly plan, and they have an application to monitor statistics and optimize, how much energy is getting utilized. He tries out that thing, and it's still a challenge. The analytics are bad. He's not really getting useful information. He's not able to, really manage the electricity consumption at different buildings. So this is a problem a data engineer would face in a city like ours in the north of Sweden. And we have more reasons to build something like Energify to solve the problems. So over to you, Nicole. You need to tell us what is Sweden missing.
Thank you, Kit. So in this case, we saw like 3 potentials where we can put our application like software. First, the financial. Like Northern Sweden is not part of the flexibility markets that we will discuss later. And this is an area of opportunity where the companies can can take advantage of that money. Also the environmental, like if the Greg is unable to see how he can optimize the resources, he will keep using the energy instead of limiting like based on the time and reduce the amount of energy that he's using. Also the social part. If there's a lack of awareness, of engagement, it will be difficult for Greg to understand how to manage this and how to socialize that to the rest of the university that don't know about the energy in here. So like discussed previously, what are flexibility markets? This is a proposal that is in that part of Sweden, like in these areas of Sweden. And how does it work? First, it would be like the flexibility service providers, that in this case, it will be like a company that will say, okay, I will disconnect during a certain amount of time that you want. I will use my own resources, I will just balance my load in order to remove from the grid part of my energy consumption, and that way you can provide that energy that you will have given to me to other users. How this works based on a bid system. The company, university that consumes the energy will say, okay, I will reduce this amount of energy by at least 60 minutes, like it can go more than that. And then they validate this, like the trend that it was going to be the energy consumed versus the one that was actually consumed. That's how they validate that the system was able to be in the flexibility. And then there are some baseline estimations to ensure that the company delivered the flexibility. We'll go to Santiago.
Yes, so basically after having all of this information, we started our technical journey. So the first thing that we needed to do is understand the data that we had available. So we had this amount of resources that we basically transformed and tried to mock up in order to understand, in this case, a university building and how the system is going to work. So for that, we needed to take the information that we had, try to make it useful, adding, for example, the data that is missing, and also, after that, applying some machine learning to also understand how is it going to be forecasted in the future. And basically, this will help us identify demands, electricity demands, and opportunities of improvement.
Yeah. Next step will be the optimization algorithms that will be explained later in detail and with examples. Go back. Go back. Okay, and then for that we're gonna take the output of the machine learning algorithms plus the real-time data, and then we're gonna give insights to Greg on how to manage the loads between the different buildings, because we're considering 6 buildings, a data center, 2 buildings for classrooms, 2 buildings for labs, and a building for administrative offices. And then after that, we develop the user interface. We use for that a Python framework called Streamlit that allows you to easily develop the application, and then it's good for showcasing the proposal. And now, here we introduce you to EnergyFi.
In a world where energy consumption impacts our future, EnergyFi was born out of the need for smarter solutions. We aim to empower buildings to consume energy more efficiently. Our vision is to create sustainability through technology. We are dedicated to transforming the way energy is utilized. Introducing EnergyFi, an interactive dashboard to optimize energy consumption. With advanced machine learning and load optimization algorithms, EnergyFi visualizes energy consumption trends and analytics. It helps save costs and provides insights into the flexibility market. Imagine a facility manager anticipating energy needs accurately. They shift workloads to times of lower electricity rates, leading to substantial savings and balanced energy usage. Join us as we pave the way for a more efficient and sustainable future.
Okay, so as you saw, we developed this product. Maybe you will see it a little more in depth now, later on. So basically, we had this monetization plan that our primary market will be building fleet owners, and then also energy managers and facilities operators. So we plan to develop an ongoing monetization plan, where after that utility companies and energy companies will be able to use it as well as and governments and municipality, especially focusing on the sustainability initiatives. And finally, we also try to get the money using two types of revenue models. The first one is the free one, which is basically normal analytics, nothing very special, but you will still have some insights. And also, after that, the B2B licensing, that it will give you more in-depth information, more analysis, and use of the data, of the machine learning models that we're going to apply. So, a little bit of the value that we bring to you is we will help you save a lot of money with these models, because you will be able to understand how your energy is being used. This also brings more efficiency, and it will help you basically improve the way the energy is used as well. So. After this.
And then in terms of analytics, since we use real-time energy monitoring, that you will see when we do the demo with the dashboard, and mixed with machine learning based predictions, well, it provides actionable insights for the energy managers and well, the managers of the university and then also from the sustainability point of view, it supports Sweden's green energy goals by minimizing the grid load and promoting smarter energy usage. And then for the innovations, we'll use that you'll see later, real-time data integration using APIs to, for example, collect the current prices of electricity in the northern part of Sweden. We're using optimization algorithms to balance the load and also mix with advanced machine learning algorithms. And it's all combined in an all-in-one dashboard that is an intuitive and user-friendly mobile and desktop app to provide actionable insights and recommendations.
In the future add-ons for our application, it would be like a power loss prevention plan, where we can see, like, in case that there is an outage for according like certain amount of time, we can protect our critical buildings and see if how much the power outage will affect us. It has some alerts where you can see, like, this building will lose power, and the other ones will work. And also using district heating visualization, this will also allow us to use that that power for heating that the municipality provides us instead of the heating that comes from the grid, from electricity.
So that's it. We hope that Greg and many more power engineers actually have a good night's sleep after using an app like ours. And the future is really green. The future is Energy 5. Thank you. We would do a demonstration of the application and...
I think we can do 2 types of demonstration, maybe, because the screen is very wide. We can use your tablet for the ones here and the computer for the... Podemos usar el computador para los que están ahí y la tablet para los que
Okay. Yeah.
So, si quieres
So we have both the desktop version and for the phone, but then let's see.
If you can do it in front of the camera.
in front of the camera.
Yeah.
So,
Santi,
I'm not sure, maybe let's just put it like this. I don't know.
let's see.
Maybe. Yep.
Yeah.
Let me go
Maybe
through
we can
the
turn off the
dashboard
light
first.
value.
Maybe can we turn off the lights?
lights?
Yes, please do.
It should be.
Yeah.
That one, yes.
Okay. Still the font here is not helping because it's white and
Yes.
that's a problem there with the wall. But okay. So here's the first, like, the launch page of a dashboard that provides real-time monitor information, and then we're using an API to get the current electricity price in the northern part of Sweden, which is the region SE1. We are getting every minute updates on the energy consumed per building. So we have, for example, the administrative office building. The names are here, but the thing is that the wall doesn't help with that.
Yes.
Like, you can see it. Well, you can see it even in the tablet as well. So we have, for example, the administrative building, the class building, second class building, data center, lab 1 and lab 2. So, and then as you can see, it changed because we're like generating real-time data. We don't have, obviously, like, it's not real data, but like we're constantly generating it, and it could be integratable with IoT devices located in the different buildings in the specific, like, categories, I don't know, heating, the air conditioning for the data center, the machines, the lighting, and that kind of stuff. And we get that information from the IoT devices, and we just put it in the real-time monitor. Then we have, well, the distribution in terms of percentage and the total real-time energy consumed. Okay, then for the policy settings, Nicole?
Yeah, because we implement
Yeah, you can already see that.
a tier-based system. So in here we will allow the Greg, the energy manager, to define, like, how much reduction for non-critical loads, like he can have, like, for example, lighting, and change the priority. We have said that the data center is the highest priority, and then it goes down until the different classrooms, but he can change, like,
As
the
you can
different
see-
policy rules, as you can, well,
Well,
as,
you can see that the policy rules was successfully.
Oh, you can
applied
see
and
it.
yeah. And this will be in combination with the different simulations that we will do. Then we have, in case that we want to implement and be part of the flexibility market, we can say we have a flexibility target of how much we want to provide with batteries that have a set of capacity and battery level, like how much is charged in the battery. And then we run the optimization of how it will look. As you can see here, like the data center doesn't suffer any loss, and the loss is distributed the other buildings. In this case, like we have the classrooms with a lower priority, they will have the biggest loss, and the labs will have like a reduced. And then it says that according to what we enter, yeah, it will be able to meet the flexibility target market. In case that is not able to meet the flexibility target market, there won't be any change here.
Yes. And then for the forecast part, based on the data sets that we got to predict, then we have, for example, we can obtain the energy consumption forecast. We can select the building that we see the forecast for, and then, for example, let's see data center, and then we can select the seasonality for the forecast, and then, for example, weekly, and then we get the orange, the real values, and the blue one, the predicted values, and then you can see the scale there. Well, you cannot even see it, but it's very
visible, yeah.
yeah. And then we can also get it daily, for example, and hourly. Depends on the seasonality that we want, and depends on the building that we select. And we can also get the next day electricity prices. We can get a prediction of it based on a history of electricity prices obtained using the mgrade.sc API. Then we have an analysis of historical data based on the data sets. Something?
Yeah, basically what we run here is just different type of analysis that we can do here. So we're showing here the average consumption. It depends on what you need, but in this case will be just the average consumption during the whole time that we have the historical data, and also the peak consumption of all of the buildings itself. As you can see here, you can have the average daily trend that we had from the historical data, and also even daily or weekly, depending on what do you want in order for you to plan ahead for this. I mean, you can create a plan after this to optimize the energy usage.
And based on our theory system, we have like a beta version of to simulate a power loss, always assuming that we have different batteries, and we set like how long will be the power loss, like in this side here, as you can see, and also how much was charged. And here you select if you want to put an additional critical building. Like imagine that you have new equipment in one of the lab buildings that you want to protect. It was not at the beginning, but you want to make sure that in case that there's a power loss, you are able to satisfy that. You can add it here, or you can. Yeah. And then you simulate, and we'll tell you how much.
That's correct, because it's in max settings.
Yeah. And it would show you how much it would change. This is still in beta version. And then we also have the district heating that
Yes. I mean, this is also in beta version, and it can be like improved later, but it will be a section of the dashboard to consider the integration of the district heating to save electricity, because as we know, the district heating is like utilizing the heating from the industries and using pipes and everything, and then getting the heating from them instead of using the electricity one. And then this is just showing a bit of data obtained, like actual versus predicted district heating consumption, but then that is in beta version, that can be improved later, like in future works. And that is our website.
Thank you.
Thank you so much
That is
for your
actually-
attention.
Do we have any questions? If not, thank you very much.